An ultrasonic welder is a machine that uses high-frequency vibrations to weld materials together instead of intense heat or high-voltage arcs. Two typical setups for ultrasonic welding are the vertical setup, which is used for welding plastics, where the vibrations are perpendicular to the weld seam, and the horizontal setup, which is used for welding metals, where the vibration motion is parallel to the weld seam. The ultrasonic welder is made up of 5 main components: the actuator, the transducer, the booster, the horn or sonotrode, and the anvil or nest. The actuator is used to move the horn towards the anvil. Pressing the plastic parts together, the transducer receives power and vibrates at a specific ultrasonic frequency. Sometimes a booster is used to increase these vibrations, which are transferred into the horn. The horn pounds the top plastic component against the bottom with every vibration, like an ultrasonic jackhammer. But the amplitude of this vibration, or the distance the horn moves when it's vibrating, is actually quite small, around 125 to 25 microns. Though the amplitude may be small, the frequency of this vibration is extremely high, hence the name ultrasonic. This vibration is also above the range of human hearing, so these machines are very quiet. This vibration causes friction between the two plastic parts, and local heating takes place. The combination of vibration, localized heat, and pressure from the actuator causes the two components to soften at the contact surface and bond together in a strong joint. The heat that occurs at this point is very localized and does not affect other areas of the plastic. This helps the components being welded together to keep their shape, strength, and structure. The horizontal setup for metals is similar to the vertical setup for plastic ultrasonic welding. But one of the key differences is that for metals to bond well, the oxide layer of the metals needs to be removed. This is achieved by changing the direction of vibration. With plastics, this direction of vibration is perpendicular to the weld line, but for metals, it is best to have the vibration direction parallel to the weld line. An actuator is again used to press the metal parts together, and then the ultrasonic vibration from the horn is transferred into the top metal component. These two components rub against each other at ultrasonic frequencies, removing oxide layers between them. This rubbing motion induces molecular friction on the contact surfaces, which in turn causes local heating. This heating does not reach the melting temperatures of the metals and is only local, meaning there is not enough heat from this motion to affect the crystal structure of the metal as a whole. Because the surfaces are free of an oxide layer, the local heating and vibrations on the contact surfaces help to form strong metallic bonds. This type of welding has a great advantage over other types because it does not affect the crystal structure and tempering of the components being welded. Now you might be wondering why these ultrasonic welders don't weld themselves together with these vibrations, or why they don't weld themselves to a table or to the factory floor. Well, imagine a rubber band. You can stretch both sides in and out, but the middle stays in the same spot. This is called the nodal point of vibration. The horn, transducer, and booster are all tuned to specific frequencies such that it is known where their nodal points are. It is at these points where the actuator is mounted to the transducer, booster, and horn section. So when the vibrations occur, these vibrations are not transmitted into the actuator, so none of the internal components of the welder are actually affected by these vibrations.